What percent of this interval consists of real numbers satisfying the inequality? Okay, this is really an Algebra 1 problem.
Okay.
Okay, so the thing we have to do here is solve the inequality.
Okay.
Okay? How do you solve an inequality? There's these things that people tell you about multiplying, and if it's negative, you switch the inequality. And have you heard about these things before? Okay. Those people don't solve inequalities for a living. The reason why that advice is bad is because, let's say I wanted to do that. X plus 1 bigger than 8 over x minus 1. What's the very first algebraic maneuver that I make?
Multiply both sides by x minus 1.
Okay, is x minus 1 positive or negative?
Positive? Or negative?
We don't know.
We don't know.
Do you see what I'm saying? Like x might be 4, x might be 0. Right?
Mm-hmm.
Both of those are valid choices between negative 5 and 5. So the very first move we make, we don't know which way the inequality goes.
Okay.
Do you see what I'm saying? So we can't do this. This is against the rules. So let's think about it like this. One way you can do this, or all the time, every time in your whole life you ever see an inequality. Again, you're not going to hear this from like the people who write the textbooks, because they write textbooks for a living. They don't actually do inequalities. Okay, so
Well, they solve the problem.
yeah, but they get to write the problem. So
Cheating.
okay, every time you see an inequality, turn it into a positive negative question.
Okay.
Meaning, instead of is this number bigger than this number, ask is x plus 1 minus 8 over x minus 1 bigger than 0. Okay?
Okay.
So, I mean, all I'm doing is I'm just saying, you sort of, how when you solve a quadratic equation, let's say I told you x squared plus 2x equals minus 1. What's the first thing you would do? You'd move the minus 1 over and put a 0 here.
Mm-hmm.
Because the quadratic formula doesn't work otherwise.
Yeah.
Right? And factoring isn't useful. So, same kind of advice.
Mm-hmm.
Okay. Now, when encountered with fractions, what do? You commonly denominate. Correct?
Okay, yeah. You commonly denominate.
Does that make sense?
Mm-hmm.
So you got x minus 1 over x minus 1. What's x minus 1 times x plus 1? You just FOIL it out, right?
Yeah.
Okay.
X squared plus or minus 1.
Right, because it's the difference of squares. So x squared minus 1
Over x minus 1.
minus 8 over x minus 1. Okay, we want that to be positive. All right. Now, at this point, we have a fraction. Okay. X squared minus 9 over x minus 1. We want this to be positive. Okay. There are two ways you can go here, and I'm going to go the way that I think is the easiest. Basically, if you follow my prescription, the first thing you're going to do is you're going to make everything, you're going to put a 0 on one side.
Mm-hmm.
Okay? Then you might do some algebra, but whatever you do, you're going to get down to a fraction.
Okay.
Simplify whatever you have into a fraction.
Mm-hmm.
Okay? Now what we're going to do is we're going to change this into an equals. How can a fraction equal 0?
The top must be 0.
Right, and what about the bottom?
Must be something other.
Must be not 0.
Must be
right? So we actually have to solve
X cannot be what?
x squared minus 9 equal to 0. And we also need to figure out when the denominator is 0.
1.
All right, so this is x is 1. X squared minus 9.
3.
Just 3.
And negative 3.
So proper technique says I factor the left-hand side, right? Okay, now here's what we're going to do. We're going to take all of the answers that we accumulated. In this case, 3, negative 3, and 1. Okay, so these three guys right here. At the very end, we've gotten numbers. All right? So what we did was we took our inequality. We're almost there. We took our inequality, we turned it into an inequality involving 0, and then we did an equality, both the numerator and the denominator.
Okay.
Now, we're going to construct a number line. All right? The three numbers that I have accumulated here, I need to mark them on the number line. Okay, so I've got 1, 3, negative 3. Okay, now I need to know whether or not I include them or don't include them. Now this is a strict inequality, so I actually would not include all three. So I'm going to indicate that with this circle.
Okay.
If it were greater than or equals, then what I would do is this. I'd still have a circle at 1, but I'd have a dot at 3 and a dot at negative 3.
Okay.
The reason why is because x can still not be equal to negative 1, but if I'm allowing the equals, then x could actually equal negative 3 or 3. All right? So, do you understand what I mean when I say colored in dot versus circled dot?
Yes.
Okay. I like to think of electric fence versus wooden fence. So an electric fence, you can get as close to it as you want, but you can't touch it.
Well, you can touch it, but...
Well, it's not advisable. Now, finally, what we've done is we've broken up the number line into regions.
Okay.
Okay, we've got region 1, region 2, region 3, and region 4. What we're going to do is test each region all the way back with our original inequality. We want to say, is this inequality true in region 1? Is this inequality true in region 2? Region 3, and so on. Okay? To do that, we can just plug in whatever number we want.
Okay.
Okay? So, for region 1, I'm going to plug in negative 100 million, billion, thousand, million, billion. Okay? What do I get? So, x equals negative 109989100193301
That's a really random number.
times 2. All right? What does that mean? So now I want to ask, is x plus 1 bigger than 8 over x minus 1? This is like asking if negative huge is bigger than close to 0. All right, something like, negative 0.0000001 something. Okay? Is a humongous negative number bigger than anything? No, humongous negative numbers are the smallest things on the planet. All right, so the inequality does not work here. Okay?
Okay.
Now,
Let's choose
for
negative.
section 2, what's the easiest one to pick? X equals 0, right? For section 3, we can take x equals 2. And then for section 4,
3.
x is 900 d million 10 to the 10 to the 10 to the 10.
Cool.
Okay? In other words, for when the regions go on forever, you can just take a huge number, and it's often very easy, right? So, for example, if I say x is huge, is x plus 1 bigger than 8 over x minus 1? So when the denominator of a fraction
That's like
is
0.
right, exactly, and this is $1 million, right? So this over here, section 4, is yes. All right, now let's plug in x equals 0. Is 1 bigger than 8 over negative 1? Yes. X equals 2. Is 3 bigger than 8 over 2 minus 1? This is no.
Yeah.
Okay, so let's go back to our thing. We've got no, yes, no,
Yes.
and yes. And of course, in practice, this happens a lot faster, but I'm explaining to you, in general, how to solve inequalities.
Okay.
You know what I'm saying? And so, like, anytime you have an inequality, you're going to do this.
Okay.
All right. So what the original question asked was to look at -5 to 5.
And decide which one.
Do you know this interval notation?
Yeah.
I mean this. And which parts of it are going to work? We said -3 to 1 works.
Yeah.
And then 3 to 5 works.
Okay.
Okay? So something like -3 up to 1. And then something like 3 up to 5. This distance right here is 4. Right? This distance is 2. Okay, the total distance is 10, so what's the percentage?
The total distance is 2, so the percentage is 2 out of 10, 20%.
4 plus 2.
Four
Did you forget about the 4?
Yeah.
Remember we had this region was 4,
That region.
right? This was -3 to 1, and then -3 to 5,
Which is 2.
and this region was 2. Okay, 6 over 10 is what percent?
6%.
Okay, not too bad, right?
Yeah.
So, in the end, how do you solve an inequality? Basically, change to greater than 0, change to numerator equals 0, denominator equals 0, split up the number line. So this is like 1, 2, 3. Split up the number line with answers from 2 and test each region. Does that make sense?
Yes.
Okay. Got it?
Mm-hmm.